Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hello guys, and welcome back to this amazing channel, Geeks for Geeks Practice. This is Abhinav, and today we are going to solve the problem missing number in matrix. This is a problem of the day for 25th of December 2022. First of all, happy or Merry Christmas to all of you. So let's start with this particular problem. Uh, Let me say the problem, and first of all, we will discuss the problem statement. The problem statement is quite simple. The problem is basically a brute force problem, basically based on the implementation skills. The problem wants to check your implementation skills, and that's all what it is. Okay, what's the problem is about? So, if you will see, this is the problem. The problem is that we are given with a matrix. So it is a n into n matrix, means n columns and n rows. Okay, it will be a square matrix, such that it has only one zero. So among all the matrices, among all the rows and columns, it will have just one zero. You have to find the positive number with which you have to replace the zero. The condition is that the sum of the numbers in every rows, every column, and the two diagonals become equal. So means if this is a matrix, if we will take a matrix, okay, let's take the example of a matrix. There are some matrices given to us which I have taken. Uh, okay, so this is how a matrix will look like. I will not fill the values, okay. So it is saying that row wise, row means row wise. Okay, then it is saying column wise, column wise. Then it is saying diagonally. The sum of numbers should be same. So what can be the number which should be replaced with the zero, the only zero present in the matrix, such that this condition holds. This is what we have to tell. Is the problem statement clear or not? Hi Rishit, hi Nakaj, hi Udit. Is the problem statement clear? Everyone who is here, just write a +1 so that I can know, and then we will start. Okay. Is it clear? Okay. Yeah. Okay. Great. Great, Rohit. Great, Rishit. Great, Priyanshi. Let's start. So, what we will do? Okay. What we will do? We have the complete number, and we know that out of all the numbers, any one of the cell will have zero. Okay. We'll have zero. So, let's see what to do. What we will do, we will take two different sets. So if we will take example, let's take this example, okay, which is 1 2 0 3 1 2 and 2 3 1. Okay, here the answer will be 0. Let's take a suitable example where the answer is not 0. Okay. So if I will take a matrix of 3 into 3, okay. Now, let's say thing is like this, okay. 2, 3, 1, 0, 1, 2, 1, 4, 1. No, this is not. Okay, so we have to handle diagonally also. We have to handle, okay. This is going to be a very confusing test case. Okay, let me see then how it can be done. So first fix a 0. So let's say that, hey, we will have a 0, okay. And let's fix a sum. Let's say sum is 6, okay. So how it can be done? So first check diagonally, and then we have to also check for the, so let's say 3, 2, 1. The sum is 6. Now here is 2, 2, 2. Sum is 6. Here is 4, 1, and 3. Okay. So we have got the matrix. We have got. You can see here. It took me 3 attempts to get AC. Okay, yes. Yeah. But here, this 0 is, no, 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 no. This is not something right. No, I'm not getting the test case. I'm not getting the test case. Can anyone suggest me a test case? It seems to be a Sudoku. Yeah, I got it. I got it. I got it. I got it. So see, guys, see. So our sum is 6. Okay. So here you can see sum is 6. Okay. Here you can see sum is 6. Here sum is 6. Sum is 6. Diagonally, sum is 6. This diagonal, sum is 6. And if you will replace this 0 with 3, the sum here will also be 6. And the sum here will also be 6. I've got it. Yeah, next. So yeah, hi, Lucky. Is it fine? This is the 0, and we'll replace the 0 with 3. Fine? Test case is clear? Okay, great. Let's start. Okay. So what we'll do, guys? First of all, we'll check for each and every row. Okay. So what we will do, we'll take 2 sets. I'm talking about sets. We'll take 2 sets. Okay. First will be the rows where zeros are not present, and second will be the rows where zeros are present. So let's take a non-zero, and let's take a 0. So the not 0. So first row is 2, 1, 3. We'll store the sum of it. So 2, 1, 3 is sum is 6. It's fine. Okay. Now, here we have a 0 and sum is 3. So we'll store it in 0. Okay. This is set. This is a set. Okay. Now, this is 6, which is non-zero. So when we will add one more 6 in this set, it will be, because set contains unique elements. Okay. Now, column wise. Okay. First column, sum is 3. But sum is 3, but there's a 0. That means we added in this particular case. It will remain 3. Okay. Now here it is 6. it will remain 6 only. Here is 6, it will remain 6 only. Because obviously, the sum of all the non-zero rows should be equal, and the sum of all the zero column and row, means where a zero is present, should also be equal. Is this clear or not? So means in this set, where non-zero rows sum is there, and where zero sum is there, there should be only one element. Why only one element? Because sum of all the rows where zero is not present should be equal. That's the case. Sum of all the rows where zero is not present should be equal. Just like here, you can see 6, 6, 6 for all the rows and columns, even for diagonals also. We will also check for diagonals. Is it clear? And now for the rows and columns or diagonal, which contains 0, means whose sum is not equal to 6. We will see the difference. So what is the difference between them? So for the rows which doesn't contain 0, the sum is 6. And for the rows who contain 0, sum is 3. Difference is 3. 6 minus 3 is 3. Means 0 should be replaced with 3. And if you replace 0 with 3, you will see that now we got the final structure where the sum of all the rows, all the columns, and both the diagonals is equal to 6 only. This is the logic behind the given problem. It is just based on the implementation. It is more about the implementation, less about because the thing is brute force only. We are not using any very specific algorithm or something like that. Okay. So can we move towards the code part? Can we? Set size should be equal to 1, not greater than 1. When the set size will be greater than 1, then the answer will be -1. Exactly, then -1. You can see here that case also exists, is it? And only gameplay. When it is greater than 1, okay, like in this case, you can see. In this case, it's fine, I think. But basically, when it will be, means the answer is not present, and then it will be -1. If no such number exists, it will be -1. Obviously, there will be the cases like no number is existing, so answer will be -1. Okay, so that's the given case for. Let's move towards the code part. So first of all, we'll take two sets. Zero and n0. N0 means not 0, obviously. Okay. First, let's check for all the rows. So rows means that row will be fixed and we will iterate to the column. So we'll first take n. Also, let's find the value of n, means the size of this matrix. Okay, so it is 1 to n. It is j. Okay. So now, guys, what we will do? We'll find a sum. So for sum, let's take a larger value because here you can see the answer is long n. Okay, this is sum. Now we will have two conditions, that if 0 is present in that row or column, we will not take it, otherwise we will take it. Okay, so we will take a boolean value. Let's say OK is equal to false. So currently it is false, means 0 is not present. Or let's call it like this. Let's call it Z. Or is 0. Is 0 means that whether 0 is present or not. So currently 0 is false because 0 is not present. Okay, now we will find the sum. Sum is equal to matrix of I and j. So it will check for each and every row firstly, means I will be fixed, first row, then I, second row, third row, fourth row. Okay, this is how it will go. Now, if whenever we will get that matrix of ij is equal to 0, so we'll make our is 0 is equal to true. Now, when this row will be done, we will check that if is 0 is present, means there is a 0 in that row. So in that case, what we will do? In that case, we will insert this into the 0 set, this sum, else into the n0. Getting or not? Got it? Is it fine? Is it clear to everyone? Here we are checking for rows. Just write a 1, then we start. Okay, great. Hmm. Okay, let's start. So now we'll check for columns. I don't know the. Okay. For columns, guys, the only thing that we will do is that change here j, here I. Means now I will change, j will be as it is. Now here we are checking for columns. Okay, that's it. Getting? Yeah. Okay, great. Now, guys, we are done with the rows and with the columns. Now the diagonals. Okay. So first of all, see this primary diagonal. So can anyone tell me the property of this diagonal? This one, the property of this diagonal, whatever I think it's called the first diagonal or the primary diagonal. Okay, this one. What is the property of this? Means the property of the cells of this diagonal. 1, comma 1, 2, comma 2, 3, comma 3. So I is equal to j. Okay. So we'll simply, so we could call it first diagonal. So we'll simply take okay. Now what we will do? Exactly. Great. What we will do? That we'll take a sum, obviously, here too, and then we'll make sum plus is equal to matrix of II. Okay, and means basically here also the same thing will be done. It's like this, and here also we'll take a is 0. Yeah, exactly. That's what we will do. Okay, so this is for the first diagonal. Now for the second diagonal, what we will do? We'll simply copy the same code. Okay. The only difference will be that with I, it will not be, it will be I minus j minus I minus 1. Okay, no, sorry, it's n minus n minus I minus 1. Am I right? Am I right? Exactly. Oh, yeah. Thanks for it. Thanks for it, yeah. That was a mistake. Thanks for it. Yeah. Thanks. Let's start. At the last, if 0 dot size equal to 1 and n0 dot size is equal to 1, then we will perform find the value, else we will return minus 1. Otherwise, as we know that what we have done here, we will take the value from not 0 and 0, we will subtract the value. Okay, so let's call it int, is fine. Int x, so what is int x? Int x is nothing but the value from, let's say, non-zero. Okay, so value from non-zero will be, simply we can take the reference of it, and the value from y is nothing but let's take the reference from the 0. Okay, now guys, there is one more case. The case is that we obviously know that the columns with non-zero, the columns, this is the corner case, okay, where maybe your code have got wrong. The corner case when non-zero is less than 0, that's also not possible. This non-zeros are always greater than 0. Okay, so if x is less than 0, then also return minus 1. Else what we will do, we will take a long end answer which will be equal to x minus y, and simply return answer. Okay, so I am submitting, guys. I don't know whether it is right or wrong. I think that we have taken all the cases. First, all the rows, okay, then all the columns, then the first diagonal, then the second diagonal, and after that, we have checked the condition. So we submit it. Seems good now. I don't. Is it that can be possible? Maybe I'm not sure. I'm not sure. But we have handled the case. Okay. Okay. So means when it was 0, then also we'll do it. It is going wrong. Line number 83. So first of all, let's optimize it so that, because we are getting wrong answer. So first of all, correct that thing. Then we will check it that what is that can be done or not. Okay. Everything seems good, I think. Sure, sure, sure. Everything seems good. I don't know what's the problem. Maybe. But overflow should not be there because we have taken uh, no. Uh, Overflow should not be there. The reason being ki our set is already a int. Set should be long int, yeah, because in set we are storing sum. Set should be long int. That was the problem. We have missed this thing in start. Set should be exactly. We have got it. That was the problem. Set should be, that was a silly mistake, obviously. Because we are finding sum, obviously, the sum of all the numbers. So it should be long or long in. So that was the problem. So yeah, guys, we have solved this particular problem. If we talk about the space complexity and time complexity, so as it was a matrix problem, the time complexity is normally order of n square, means where we just iterate through all the cells, and space complexity as we've taken two different sets, so it will be order of 2n. Yeah, yeah, sure, sure, is it? We can do that. Let's see this. Yeah, we have got a wrong answer, is it? After that. So this is the test case. You can check this test case. On this case, it is giving wrong answer. So you can check that now. Getting? Yeah, this seems fine. Okay, seems fine. Great, guys. Okay, then, thank you for watching this particular live. I hope that this was helpful for you guys. Okay, this was the problem. The problem was basically based on the brute force and the implementation skills only. Yeah, thanks, Nancy. Thanks for it. So, great, guys. Let's meet next week, because now Saturday Sunday period is done, and now we'll meet next Saturday. Thanks, Rishit. No, Nakul, actually, I have my exam tomorrow. I haven't got the chance to solve that. I can, you can connect with me on LinkedIn. Okay, we'll talk on LinkedIn. I think you are not connected, so we will talk on LinkedIn regarding that after my exam tomorrow. Okay, after my exam. Currently, I have my exam tomorrow of OR, operational research. So that's the reason I was not able to do it. Thanks, Odisha, Odisha developer. Thanks. So that was it, guys. Yeah. Okay then, thank you. Have a nice day for tomorrow. Good night. Happy coding. GFG कर लो हो जाएगा.